Welcome. We're going to solve some quadratics here, looking at x-intercepts and using vertex form as needed. All right, so on this one, the x-intercepts are important because they're the solution for the equation of f of x equals 0. The process to find the x-intercepts of any quadratic function, that's what we're looking at, the process. And really, it's factoring vertex form, completing the square, and quadratic formula, which will come up later in this task. So as an example, you always want to try and factor these first. So if it's x squared minus 2x minus 3, that means that you can, it's negative 3 and 1. So x minus 3, x plus 1. Therefore, you can see at negative 1 and 3 are our x-intercepts. The line of symmetry, so negative 1 plus 3, it's the halfway point. Okay, so in this case, it's 2 halves, which is equal to 1. So the equation is x equals 1, and then you would have a line of symmetry. What is the vertex? So if the line of symmetry is at negative 1, actually it's not negative 1, it's positive 1, right? If it is at positive 1, it would be f of 1. So if we plug that in, 1 minus 3 times 1 plus 1. So that's negative 2 times 2 is negative 4. So the vertex is at 1, negative 4. And there's the vertex. So parabola is kind of something like this. And the minimum value is at 1, negative 4. Here's another one. Oh no, same one. What are the x-intercepts? Well, the x-intercepts we calculated are at 3, 0, negative 1, 0. And that's because it makes each of these expressions equal to 0. How far are the line x-intercepts from the line of symmetry? So 1 minus 3 and 1 minus negative 1. You can see that it's 2 to the left and 2 to the right. If you know the line of symmetry is at x equals h, so we're generalizing, let's just call this h, and you know how far the x-intercepts are from the line of symmetry, how would you find them? Well, in this case, you can do h plus 2 or h minus 2, because you're saying you know how far already. If you didn't know how far, you could do h plus some distance and h minus some distance. What is the value of f of x at the x-intercepts? Is always f of x is equal to 0. Okay, let's do one more example. Here they show you. Here's the line of symmetry. It's at x equals h. The distance is given as d. So the intercepts are at h minus d0 and h plus d0. So there's another one that goes over here where you're subtracting d. So then they give you another one. This time you're not able to factor it, so they're asking for vertex form. So we'll set it equal to 0, and we're going to say x squared minus 6x plus 4, and we'll use the complete the square, x squared minus 6x plus 4. Half of negative 6, if you square it, you get 9. So we now have x minus 3 squared minus 5. If you're to add 5 to both sides, you now have, I'm going to write x minus 3 on the left now, x minus 3 squared equals 5. And then we can use that. Let me just take that. And let me just get rid of some of this here so we have a little bit more room. Okay, so here's what we've got now. X minus 3 quantity squared equals 5. If we take the square root of both sides, we can say that x minus 3 is the square root of 5. If we add 3, we can say that x is equal to the square root of 5 plus 3. And there's going to be a positive and a negative solution here, so we say plus or minus the square root of 5. Okay. And then from this, you can say, oh, okay, wait a second. If that's the vertex must be at 3 here. X equals 3 for the vertex. And if you plug that in, 3, you get 9 minus 18 is minus 9 plus 4 is minus 5. The line of symmetry is at x equals 3. What do you estimate the x-intercepts to be? Well, let's go straight to the value first. So we've got 3 plus the square root of 5, and we've got 3 minus the square root of 5. Okay, and these are our x-intercepts. Okay. And then you could estimate that. Square root of 5 is greater than 2, but less than 3. So it's a little bit less than 6 and 0, so it's probably something like that. 1, 2, 3, 4, 5, 6, and something like that. Okay, so D between 2 and 3, we could say, oh, I don't know, you could say 2.5 if you wanted to. Okay, using the vertex form, write an equation and solve it to find the exact. That's actually what we did. We found the exact values. So it was 3 plus the square root of 5, and it was 3 minus the square root of 5. Okay, so the exact value of D is the square root of 5. And then you could go ahead and use a calculator